Good morning, everyone, and the class looks quite bright today. It's a bright new day, and we are into lecture number 19. And if I remember correctly, we were dealing with microscope in the previous class. Now, again, as I told you, to go through compound microscope. We had started with compound microscope, but before going on to compound microscope, let me give you a quick recap of what we had done for simple microscope. Let me find my pen. My pen is here, here. Where? So my pen is here. Okay. What were the things that we remember about simple microscope? I hope you all can see this. Okay. What are the things that we remember about simple microscope? Number one, a simple microscope is nothing but a convex lens. Yes or no? Can I have some raise hand that we remember this? A simple microscope is nothing, a single lens, a single convex lens that behaves as a simple microscope. Number two, where is the object placed? Where should be the object for a convex lens to behave as a simple microscope? It must be placed between the focus and the pole so that the image that we get is virtual and it is enlarged. I hope you all remember this. The image has to be virtual and the image has to be enlarged because that is the main criteria for it to be called as a microscope. Then the third thing is we had seen that the magnifying power of a simple microscope is nothing but beta divided by alpha. Beta is the angle subtended by the object at the lens or the microscope, and alpha is the angle subtended by the object for an unaided eye when the object it has least distance of distinct vision. Do we remember this? Can I have some raised hand that we remember this? Okay, and when I put the values of beta and alpha, the answer that I get is d by u, or I should call u naught. Not or zero standing for the objective lens. There is only one lens, so that is objective as well as the eyepiece here in this case. Now we had seen two cases here where case number one, the image is formed at infinity. Do we remember this case? When the image is formed at infinity, yes or no? And for that, the magnification power m becomes d divided by the focal length f. Then we had seen case number two when the image is formed at least distance of distinct vision, that is d. In that case, the formula of magnification becomes, I did it wrong, so I'll just rub it off. The formula for magnification becomes 1 plus d by f. So far, so good? Do we remember all this? If you can't remember these 5 points, there cannot be a question that comes and you are not able to solve it. This was a quick recap of what? A quick recap of simple microscope. Then from simple microscope, we moved on to a more complex device, a more better microscope. Remember, the main job of a microscope is to give you an enlarged image. Now, the simple microscope only consists of one lens. It will give you an enlarged image, but that may not be very big. So, if the object is very small, you may not be able to view it very nicely in a simple microscope. If you cannot view it nicely in a simple microscope, then what do? You upgrade. Everything is upgraded. Human mind also gets upgraded. The laptop gets upgraded. Your mobile phone gets upgraded. iPhone for 13, 14, 15. I don't know how many iPhones you will have. Everything gets upgraded. Similarly, you have this microscope getting upgraded. And how do I upgrade a microscope? We can make a compound microscope. Instead of one lens, we put two lenses. Lens number one is Lens number one is the one which is near to the object, smaller lens, smaller aperture, smaller focal length. That is known as the objective lens, and the other one is the eyepiece or the eye lens. Do we remember this? Yes or no? Then what happens is we have an object. As you can see, the object is right here. And remember, where is the object placed? The object is placed between F and 2F. Do we remember this? Yes or no? The object is placed between F and 2F. What is the reason of placing it between F and 2F? When the object is between F and 2F for a convex lens, the image is real, image is enlarged, and image is inverted. This is the image A dash B dash that is formed by the first objective lens, objective lens. Now, this image will act as an object for the second lens, the bigger lens with a bigger focal length. And for this to happen, this will now create a more enlarged image of the same object. This is the final image. Now remember, this image should be formed between F, E, and the pole of the eyepiece. Do we remember this? Yes or no? So that I can have a enlarged image for a compound microscope. This is how a compound microscope functions. This is all that we did in the previous class. Now we have to move to the next thing, and again, whenever we are dealing with optical instruments, whenever we are dealing with optical instruments, we are dealing with their magnifying power, because that is what they are supposed to do. They are supposed to magnify. The microscope is supposed to magnify, make smaller object bigger. Only thing that matters is the magnifying power. Now, how do I find the magnifying power of a simple microscope? We already know the formula, beta divided by alpha. What happens to the magnifying power of a compound microscope? And here is the magnifying power of a compound microscope. Remember, this compound microscope consists of two lenses. It's a combination of two lenses. Now, when you have more than two lenses, more than one lens, 2 or 3 or 4, the magnifying power gets multiplied. Do you remember this? The magnifying power of the combination is magnifying power of the first multiplied by second, multiplied by third, multiplied by fourth, and so on. Do we remember this? Yes or no? No or yes? Similarly, we can have the magnifying power of a compound microscope. This is the magnifying power of the objective multiplied by magnifying power of the eyepiece. You can remember it in this way as well. Do we remember this? Do we understand this? Magnifying power of the objective. Objective is the first lens multiplied by the magnifying power of the eyepiece. So you can call it as linear magnification multiplied by angular magnification. Linear magnification is caused by the objective lens, and the angular magnification is caused by the eyepiece. And this is the formula for the magnifying power. Magnifying power of the objective multiplied by magnifying power of the eyepiece. Now, to understand the magnifying power of the objective, it is a simple convex lens. It is V0 divided by U0. Do we remember this? Yes or no? Can I have some raised hand that we remember this? Magnifying power of the objective is V0 divided by U0. Distance of the image. divided by distance of the object, or height of the image divided by the height of the object. That is the magnifying power. Multiplied by, if you look at this term, d by ue, and let me highlight it for you if I can. I will try. If you look at this term, d by ue, this is the magnifying power of a simple microscope. Do we remember this? So, when you multiply the magnifying power of the first lens, V0 by U0, and you multiply it by the magnifying power of the second lens, D by UE, whatever you get is the total magnifying power of this compound microscope that you have created. Is it clear to everyone? Yes or no? Yes, so I'll give you a minute to note this down. Please note it carefully. Well, since we have done this formula, now you must understand that there are two cases that are possible in this compound microscope as well. What will be the two cases that are possible? There are two cases that are possible. The first case is when the image is formed at infinity. The image is formed at infinity. That is the first case. What about the second case? The second case would be when the image is formed at the least distance of distinct vision. Do we understand this? Whenever we are dealing with optical instruments, we'll have to deal with magnification in two cases. Case number one, image is formed at infinity. Case number two, image is formed at capital D. Do we remember this? So, we do the first case first. And the first case is when the final image is formed at infinity. Final image is formed at infinity. That is the first case that we are going to do. It is given in your sheet. So I'm just showing you a part of your sheet. And here it comes. When the final image is formed at infinity, you don't have to look at how it has been derived. You just need to understand when the final image is formed at infinity, the distance of the object from the eyepiece is Fe. Do we understand this? The object must be at the focus of the eyepiece, then only the image will be formed at infinity. Yes or no? So UE becomes equal to Fe. This was my original formula. Magnifying power is V0 divided by U0 into D by Fe. D by UE. Here, in place of UE, if you can see, Fe has been put. Do we see this? In place of UE, Fe has been put. We have substituted UE by Fe. Do we see this all? So this becomes the formula for magnifying power of the compound microscope when the final image is formed at infinity. Now this formula can be written in number of ways. This is way number one, V0 by U0, D by Fe. This is way number two, where we have put the value of V0 by U0 from the equation, the lens formula. This is the third way of writing the same equation. We have put the value of V0 by U0 in terms of F0 and V0. This is the fourth way. This is the fourth way of writing the same thing, where V0 by U0 has been replaced by H2 by H1. Do we understand this? H2 is the height of the image. H1 is the height of the object. Do we understand this? Can I have some raised hand that we understand this? Everyone in the class, do you understand this? So these are the 4 different ways in which you can write the same formula. Now, one of the most important things that they might ask you is given at the very last line. You see that very last line? This very last line asks us the length of the tube. Do you see this length of the tube, gentlemen and ladies? Oops, wrong color. Do you see this length of the tube, gentlemen? Length of the tube. Do you see this? Now the question would arise, what the hell is this length of the tube? What the hell is this length of the tube? Can anyone tell me what do you mean by length of the tube? Understand that you cannot right now comprehend it. So what I'll do is I'll give you a minute. I will give you a minute to write everything. Just do not write that length of the tube still. Just write the formula for magnifying power of a compound microscope when the image is formed at infinity. Write formula number 1, 2, 3, 4. We'll come to length of the tube once you are done with this. I'll give you a minute to do this exercise. Doraemon has, and this is the time machine, and I go back in this time machine to this diagram that I showed you many times. Now, looking at this diagram, you can understand what is the length of the tube, what is actually the microscope. The microscope starts from here, and I will mark it by red so that it looks different. The microscope starts from here, and the microscope ends here. That is the length of the microscope or the length of the tube. Now you can very well understand what is the length of the tube of the microscope. Do you understand this? What will be the length of the tube of the microscope? Yes, I see raised hands. So now you know the answer, but only thing is you cannot express it. Sometimes I stumble. Okay, but you cannot express it. I am going to express it in my language, which is obviously your language. The length of the tube is nothing but, sir, it is the length from here to here. That is known as the length of the tube L. And as you can very well see, the length of the tube is nothing but V0 plus UE. If you add these two things, remember they are numerical values, not with signs, because if you add with sign, one is positive, other is negative, you will get confused. Oh, so don't add them with sign. V0 will be positive, but UE will be negative. So when you add them, they actually get subtracted. You cannot subtract them because you have to find out the length of the tube. So remember, you can write the formula of length of the tube as V0. V0 is always positive plus the absolute value of UE, because UE is going to be negative. This side is positive. And when you measure from this side, it will be negative. So UE will be negative, but V0 will be positive. But you will have to add the two positive values to get the length of the tube. Do you understand this? Can I have some raise hand that you understand this? I'm not getting raise hands from everyone. That is sad. Do we understand the length of the tube? Yes, so the length of the tube is V0 plus the absolute value of UE. And I'll give you a minute to do it in your sheets. So as always, we move ahead. We have seen that the length of the tube of a compound microscope is nothing but V0 plus the absolute value of UE. And that brings us back to the discussion point, and we were discussing what will happen when the image is formed at infinity. We have seen formula number 1, 2, 3, 4, different versions of the same formula. Now we come to length of the tube, which is being highlighted in yellow. The length of the tube is always equal to V0 plus the absolute value of UE, whether it's positive or negative, we always take positive. Here, the value of UE, as you can see, open your eyes, bacha, you know that the value of UE is Fe. Can you see that? The value of UE is Fe. I've highlighted it for you. Do we see this? The value of UE is Fe, and therefore the length of the tube becomes V0 plus Fe. I have not put the absolute value sign here. I have not put the absolute value sign here. I have not put the absolute value sign here because I know that FE is positive. Focal length of a convex lens is positive, and that is what you got to remember. Therefore, we have given you the sign convention as well. And remember this. You may not be solving a numerical, but remember this. U naught is negative. Do we understand this? V naught is on the other side. Real image, it is positive. F naught is the focal length of objective. It is positive. FE is the focal length of the eyepiece. It is positive. UE, distance of the object from the eyepiece, is negative. BE, distance of the image from the eyepiece, is negative. M naught, magnification produced by the objective, is negative. ME, magnification produced by the eyepiece, is positive, and the entire magnification is negative. Can I have raised hands from every one of you that we understand this? I'll give you a minute to note everything down. Whenever we have devised the formula, that formula has to be put with proper sign convention. I'll give you a minute to note this thing down. We are done with the first case. Image is formed at infinity. When you are done with this, we'll move on to the second case where the image is formed at least distance of distinct vision. I'll give you a minute to note these things down. Well then, let's move on to the next case. And in the next case, we are going to see what will happen when the image is formed at least distance of distinct vision, which is nothing but capital D. And you remember, the formula is P naught by U naught into D by UE. We just have to put the value of D by UE. And remember from simple microscope, in case of image formed at least distance of distinct vision, your D by UE was coming as 1 plus D by F. Yes or no? I can't highlight it, so I'll just leave it. It was coming as 1 plus D by F. Here also it is coming as 1 plus D by F. The only thing is it is 1 plus D by FE. So we multiply it by U naught by V naught, and we get our formula number 1 for magnifying power in case image is formed at D. This is number 2 way of writing the same thing. V naught by U naught is put in terms of F naught and U naught. This is way number 3 of writing the same thing. And this is way number 4 of writing the same thing. The only thing that has changed that instead of D by FE, now we have D by FE plus 1. And the length of the tube, in this case, here UE is not equal to FE, and therefore we use the actual formula P naught plus the absolute value of UE. Do we understand this? Can I have some raised hands? Okay, so if you understand simple microscope, compound microscope becomes a very, very easy thing to understand. The only thing that is different is magnifying power gets multiplied. P naught by U naught is the additional term that is put there. If you understand this, we are good to go. I'll give you a minute to note this down. Now is the time that we move forward, and we are done with microscope. And this is the time where we are going to solve a few questions, 2 or 3 questions based on the concept of microscope. And here comes the first question, question number 1. And the question goes like this. The focal length of the objective of a microscope is A, B, C, D. Which one is correct? Waiting for your answers patiently. Straightforward question with a straightforward answer. Yes, bacha, what is the answer? 1, 2, 3, 4. I can see your fingers now today. got my iPad working. So 1, 2, 3, 4. What is the answer? Kajal, what is the answer? What about the focal length of an objective of a microscope? I told you that many times. Is greater than the focal length of eyepiece, lesser than the focal length, equal to the focal length, any one of A, B, or C. Which is the correct answer? 1, 2, 3, 4. And the answer is very sad. The answer is 2. It is lesser than the focal length of the eyepiece. I already discussed this point with you. Convex lenses, the objective is smaller, eyepiece is larger. I showed it in the diagram as well. Very disappointed that you could not give me the answer for this one. Well. What to do? Let us move on to the next question. The first question, I was pretty confident that you could give me an answer. The second one, I am not so confident that you can give me an answer. Question number 21 from your sheet. But still, hopes run high. And this is, you can give the answer more practically rather than using any physics. When the length of the microscope tube increases, when you increase the length of the microscope, I hope you have seen a microscope and operated on it. Because of pandemic, you might not have gone to a lab, different case. I hope you can see this and you can answer this by your pure common sense or logic. When the length of the microscope tube increases, remember the word increases, what happens to its magnifying power? A, B, C, D, it decreases, it increases, it does not change, may increase or decrease. God knows that. Waiting for your answers, bacha. A, B, C, D. Increases, decreases, remain same. I don't know what can happen, sir. I have never seen a microscope, sir. What is the answer? I can't see your finger. It's just too bright outside. You can just move it towards the side of the ball. And the answer is 1. Yes, it will decrease. It will decrease. The larger the tube, the smaller will be the object that you see. More on common sense. And remember this. Let us see if you can do this. I have high hopes that you would be able to give me the answer for this one. And here comes the question. The final image produced by a compound microscope is 10, 10, 10, 10. The final image produced by a compound microscope is what? A, B, C, D. Real and elect. Virtual and elect. Virtual and inverted. Real and inverted. And if you understand, if you have seen compound microscope diagram, you will quickly give me the answer as 3C. It is virtual, it is enlarged, and it is inverted. Remember, it is not real and inverted, it is virtual and inverted. Will you remember this? That finishes our, these are the type of question that you will encounter in a microscope, only formula based. You may not be encountering question where you have to solve numericals. And let me see if I can get more questions here. Let me just check out. Must be having more in the bank for this one, for microscope and telescope. Let me see if I can give you one or two more from any of the examinations. See if I can find, looking at the entire spectrum of questions. Where do I have a question that I want to discuss? Questions are more on lenses simply, and they are not here on optical instruments. Only one or two questions are there which we have already covered. So let us move on to the next topic. Okay, I got this question from your sheet, and let us do this so that you will get at least one numerical. It's better to do at least one numerical. So let me do this, and here it comes on your screen. A thin convex lens of focal length 5 centimeter is used as a simple microscope with a person with a near point or D as 25. What is the magnifying power of the microscope? Can you give me the answer for this one? A simple question based on the formula that we have done for a simple microscope. Then we will do one for compound microscope, and that will cover the entire spectrum of questions. I'll give you a minute to do this. Okay, let us see how we are going to solve this problem. Now, the problem with this problem is we don't understand, or it is not given clearly where is the image formed. The image can be formed only at two places. Do I have your attention, bacha? The image would be formed either at infinity or at the least distance of distinct vision. Here in this question, my dear friends, it is not mentioned where is the image formed. So what will you imagine, or what will you take? Well, the near point is given to you. The least distance of distinct vision is given to you. So here we'll have to imagine that the image is formed at least distance of distinct vision. We understand this. We can just put the formula for, oops, strong colors. You can just put the formula for a simple microscope and image formed at least distance of distinct vision. The answer becomes very simple. For least distance of distinct vision, the formula is 1 plus d by fe. Just put the values. D is 25, focal length of the eyepiece. Here there is only one lens. Is 5, 25 divided by 5 is 5, 5 plus 1 is 6. So the magnifying power is 6 times of the original object. Do we understand this? Can I have some raise hand that we understand this? Okay. I'll give you a minute to note this down, and then we will move on to the second question. And I would be very happy if you can solve the second question. I hope that you can do this. That will tell me that we are done with microscope, so that we can move on to the next topic. I'll give you a minute. What do? Is we move ahead and we move on to the next topic. And the next topic is telescope. So here comes the next one, telescope. And the first one that we see is known as astronomical telescope. Telescope which is used to see stars and galaxies and other stuff. Telescope, astronomical telescope. And the first thing that you will do is to draw this diagram. Draw this diagram for an astronomical telescope. What are the things that you must see? What is this thing known as? The first thing that I marked. I hope you can see it on your big screens. The first thing that I've marked is your objective. Yes or no? This is your objective, so I write O. And this gentleman is your eyepiece, I write E. Now, do you see the difference between an astronomical telescope and a simple microscope? Can you now tell me the difference looking at O and E? Look at compound microscope ka diagram. Look at the astronomical telescope ka diagram. What is the difference between O and E, objective and eyepiece? In compound microscope, we have seen that the objective is smaller and the eyepiece is bigger? Yes or no? And here you see what is the case. It is the exact ulta. So if you ulta karo the microscope, it probably becomes a telescope. Do you understand this? If you ulta karo the microscope, don't do it. Lab, you will go and you'll say, oh, okay, I'll do it ulta and I'll make it a telescope. That may not work because the microscope might be pinned to the table, and if you try to do that, it's heavy and you might incur some heavy penalties on doing that. So do not say that Aastik sir has told me ki ulta karo the microscope and telescope is there, so I'll make the telescope from a microscope. But this is how you can vaguely understand this. Ulta karo of telescope is compound microscope, ulta karo of compound microscope telescope. In terms of the lenses that we are seeing, objective here is having larger focal length and the eyepiece here is having smaller focal length. Do we understand this? Now, as you can see, as you are watching distance object, so the object is placed at infinity. The rays are coming parallel. Do we understand this? So the distance of object UO is nothing but infinity. And when the object is placed at infinity, where is the image formed? As you can see, the image will be formed at the focus of the objective. Do you see this? Please open your eyes and see. The image is formed at the focal length of the objective lens, and that is why we need a objective lens of large focal length. The image is formed at the focus of the objective. Now, wherever this image is formed, you can look at this focal length of the eyepiece. The focus point of the eyepiece is here. The image is formed in such a way that it lies between the focus and the pole of the eyepiece. Do you see this? This image will act as an object for the eyepiece, and this eyepiece will create an enlarged image of the objective. F0 is the focal length of the objective. FE is the focal length of the eyepiece. UE is the distance of the object from the eyepiece. PE is the distance of the image from the eyepiece. Alpha again is the angle that the object subtends for normal eye. Beta is the angle subtended by the instrument for the same object. Do we understand this alpha beta? Do you see alpha beta? So these are the things that you must note down in this diagram. Please draw this diagram carefully. Remember all the points. Objective is bigger, eyepiece is smaller. The first image is formed at the eyepiece. This image will act as an object for the eyepiece. The first image is formed at the focal length, at the focus of the objective. This will lie between the focus and the pole of the eyepiece, and the eyepiece will create a virtual inverted enlarged image of the object. Alpha, beta, V0. V0 is not there. V0 is equal to F0, FE, UE, VE. Please mark all these things. I'll give you time to do this. Then we move on to the formula for magnification. What does a telescope do? Every one of us knows this. A telescope is used to see distant object. Objective lens forms the image at the focus. Remember this. This image acts as an object for the eyepiece and it forms the final image A dash B dash, already discussed in the diagram. Magnifying power is again beta divided by alpha. You put the value of beta by alpha, you don't have to remember that value. The magnifying power comes as minus F0 by UE. So remember this, magnifying power is minus F0 divided by U. Will you remember this? That is the only formula that matters. Please remember this formula. I'll give you a minute to note down this. Minus F0 by UE is your final formula. Okay, then. Again, we come to the same scenario. There will be two cases here. When the final image is formed at infinity and when the final image is formed at least distance of distinction. This is case number one. The final image is formed at infinity. So the value of VE is infinity, the value of UE will become equal to FE, and the formula will become simply, instead of UE, you would have FE, and the formula becomes minus F naught by FE. Do we understand this? I will need raised hands from all of you. That is the first thing. The next thing which we again did not discuss is the length of the tube. The spelling of the length is wrong. The spelling of length is wrong. Again, I will go back to the diagram and show you what is the length of the tube here. But before going on to the length of the tube, please write the case when the image is formed at infinity. What is the magnifying power? Remember, the magnifying power is always equal to, for an astronomical telescope, minus F naught by UE. Here UE becomes equal to FE. Therefore, the formula becomes minus F naught by FE, my dear friends. I'll give you a minute to note it down. Then we'll go back and see the length of the tube in case of an astronomical telescope. A minute to win it. Now that takes us back to the question, what do you mean by the length of the tube? And again, the answer is same, the length of the tube. The telescope starts from here. The telescope starts from here and it ends here. So you have to find the distance from here to here. The distance from here to here is F naught. The distance from here to here is UE. So if you add these two distances, this becomes the length of the tube L, and the value of the length of the tube L is simply F naught plus the absolute value of UE. Why I'm using absolute value of UE? Because UE in terms of sign convention is negative. Do we understand this? Yes or no? So the length of the tube for an astronomical telescope becomes F naught plus the absolute value of UE. This is the point that you will note down. Again, going back to the diagram, mark the length of the tube as L. This question can come in the examination hall. So please note it down. I'll give you a minute to do that, and then we'll come back to the formula and see what will the length of the tube in this case. In the case where image is formed at infinity, and I'm sure you will be able to give me the answer. So I'll give you a minute to think about both the cases. That takes us to the next part, and we will now go back to the infinity wala case, and we'll look at the length of the tube. Length of the tube is always equal to F naught plus the absolute value of UE. Here, UE is equal to FE, and FE is positive, so though I don't have to use the absolute value wala sign, and the answer becomes F naught plus FE. That becomes the length of the tube for the astronomical telescope, where the final image is formed at infinity. Do we understand this? I'll give you a minute to note it down, and then we will move on to the next case. And the next case is image formed at D. Please note it down. Well, then we move on to the second case where the image is formed at least distance of distinct vision. Again, you don't have to remember, again, you don't have to remember all of this. Just take this out, take this out. You just remember the magnifying power. The magnifying power is always equal to minus F naught by UE. In this case, the formula becomes somewhat different. Minus F naught by FE was the formula in case number 1. Here it is multiplied by 1 plus FE by D. Don't get confused. This is how the formula comes. And the length of the tube is F naught plus the absolute value of 2E. So please note this down. Formula looks are somewhat different, but please note it down, and I'll give you a minute to do this, and then we will try to wrap up this particular topic. Okay, Here we come. And I said this is a very important aspect, that you understand the difference between a compound microscope and an astronomical telescope. I told you if you ulta karo microscope, it becomes a telescope. That is not very correct. But this is how to understand the difference between the eyepiece and the objective lens. The first difference is this is used to increase the visual angle. Smaller object becomes bigger of nearby tiny object. So microscope is used to enlarge the image of a tiny object which is very nearby. It is used to enlarge the visual angle of objects which are very far. So telescope and microscope, that is a basic difference. In the field, and both are convergent and of short focal length and aperture. The focal length is short. In it, objective is of large focal length and aperture, while eyepiece is of short focal length and aperture, and both are convergent, convex lenses. Final image is inverted, virtual and enlarged, and at a distance d to infinity from the eyes. Here also the same case, inverted, virtual, and enlarged. Magnifying power does not change if the objective and eyepiece are interchanged. So if we change eyepiece and objective, the magnifying power does not change. Here the magnifying power becomes 1 by m square if the objective and eyepiece are changed, because it is f naught divided by fe. If you change the objective and eyepiece, the ratio becomes ulta. Magnifying power is increased by decreasing the focal length of both the lenses. Magnifying power is increased by increasing the focal length of the objective and by decreasing the focal length of the eyepiece. As you can see, if you increase f naught and you decrease fe, the magnifying power will increase. So please remember all these 5 points. I'll give you 2-3 minutes to write each and every point. Do we understand this? You'll have to remember this, because any of these points can come as a question, either a question on compound microscope or a question on astronomical microscope. 1 or 2 points are still left, which I'll do once you are done with these points. That takes us to some question and answer on an astronomical telescope. And here comes the first question. In an astronomical telescope, the final image is formed where? A. Least distance of distinct vision. B. Focus of the objective lens. C. Focus of the eye lens. And D. Infinity. What do you think is the correct answer for this one? An astronomical telescope, where is the final image formed? We have seen 2 cases. Do we remember those cases, bacha? Yes or no? No or yes? So what is the answer that you have? This is question number 24 from your sheet. So the answer is either A or D. We have seen when the final image is formed, the final image can be formed anywhere between D and infinity. We have seen 2 cases, so it could be least distance of distinct vision, but the final image, the best image you will see when the image will be formed at infinity, because that is where you will see the most magnified image. So you can mark D as an option here. This is the case where we set it normally, and therefore the answer should be at infinity. Remember the final image, depending on the adjustment of the tube, we can make the image to form at any place between D and infinity, as in the case of a microscope as well. Do we understand this? Okay. Remember, whenever we talk about a microscope and it is not mentioned where is the final image formed, we'll always assume that the final image is formed at least distance of distinct vision, because the object is very near. Do we understand this? For a microscope, Whenever nothing is mentioned, we'll always assume that the image is formed at least distance of distinct vision. But for a telescope, whenever nothing is given, we'll always assume that the final image is at infinity, because the telescope is not going to bring that object close to us. Do we understand this? I'm not having raised hands from all. So for a microscope, always take it as D. Object is very near. For telescope, object is very far, and that is why infinity. Let us see if you can solve this question, and I would be pretty happy if you can give me the answer for this one. Straightforward question with a straightforward answer. Remember, it is not mentioned where the final image is formed. That is what you have to use your head. An astronomical telescope has a magnifying power of 10. The focal length of the eyepiece is 20. What is the focal length of the objective? And the answer is pretty simple. Even without calculating anything, you can tell me the answer. Without calculating anything, you can tell me the answer. Remember, my dear friends, eyepiece is 20. Oops, eyepiece is 20. Objective is always focal length is more than the eyepiece. There is only one option which is more than the focal length of the objective of the eyepiece. Yes or no? And the answer is 200. The formula is minus f naught by ue. It is not mentioned where the image is formed. So we'll assume that the image is formed at infinity. If the image is formed at infinity, this fe becomes ue becomes fe, and you can find out the formula for focal length of the objective. Focal length of the objective will be m multiplied by focal length of the eyepiece, 20 multiplied by 10, and the answer is 200. Do we understand this? Can I have some raise hand from everyone that we understand this? Yes or no? No or yes? Comes the next one, the last one for this particular topic, and then we'll move on ahead in life, because life has to move ahead. Time only goes forward, time does not go back. Next one, let us see who gives me the answer for this one. The magnifying power of an astronomical telescope can be increased. Can be increased. And the options are right in front of your eyes, and I'm waiting for the correct option. Remember, it is not mentioned where the image is formed. You will always assume that the image is formed at infinity. And what is the correct answer? I can't see your fingers, beta. It's white light coming, sunlight coming from outside. It's too dark on the yes. This is better. This is better. So what is the answer? Always put your fingers in the lighter shade. You see, lighter shade the fingers are clearer. Darker shade the finger may not be so clear. Lighter shade means the wall. Answer is by increasing f naught by fe. So you increase the focal length of the objective, or you decrease the focal length of the eyepiece. That will help you in increasing the power, the magnifying power of the astronomical telescope. Do we understand this? Second option is wrong. Third option is wrong. Fourth option is definitely wrong. The only correct option is option A. That finishes our discussion of astronomical telescope and compound microscope. What we have done today in the class, folks, we have seen what is a compound microscope: smaller objective, bigger eyepiece. Image can be formed from infinity to least distance of distinct vision. If nothing is mentioned, it will be D. We have seen the formula for magnifying power. We have seen if you increase the length of the microscope, the magnifying power decreases. Then we come to astronomical telescope. It is ulta of microscope, not exactly ulta. The objective is having a larger focal length. The eyepiece is having smaller focal length. The first image is formed at the focus of the objective. The length of the tube is f naught. Where's the sound coming from? Strange sounds comes from somewhere. Okay, the length of the tube is f naught plus the absolute value of ue. We have seen what is the formula for magnification in case the image is formed at infinity, which is the default case. In second case, the image is formed at least distance of distinct vision. We have seen those formulas, and in the next class we'll wind up ray optics and probably start with wave optics. I'll send you the sheet just now after this class. The only thing that is left is defects of vision. We'll try to wrap up in the next class. Go through the notes. You better know what is myopia and hypermetropia. I have short-sightedness probably, and I'll try to correct it as well. I'll go to an optician and get my eyes checked. But before getting my eyes checked, I'll again see what is myopia and hypermetropia and how we can correct it. That will be in the next class. I hope you are there. Next class is tomorrow. And tomorrow is a good day. Every day is a good day. Take care. See you in the next class. If you have any doubts, you can always find me. I'm everywhere. I'm omnipotent and omnipresent. Okay. Take care. Have a nice day.